Guys, in this tutorial we will be dealing with Poisson's ratio. So what is Poisson's ratio? So before I give you the definition, I will show you an example. So this is having a width. You note the width. So when you apply a axial force, can you see that the width is reducing? So there is some relationship between the longitudinal elongation and the lateral, that is parallel to the width. Lateral is parallel to the width, longitudinal is perpendicular to its width. So there is some relationship between the lateral and linear expansion. Okay, so when you apply force, see that there is a decrease in the width. Okay, it is the lateral ratio of lateral strain to the linear strain. So it is denoted by the letter nu. This nu is lateral strain divided by linear strain. So we have seen the example. You have something which is applied by a force P, and when after the application, this is the initial dimension. Okay, after the application you can see that there is a decrease in the width. There is a decrease in the width. Width is reduced to this much. Actual width was this much. Decrease in the width and increase in the length. This decrease in the ratio of this deformation to the longitudinal deformation is called mu or Poisson's ratio, because it is analytically experimented by the mathematician Poisson. Okay, in general we use the minus term here to make the mu value positive, because you see the example as when this is applied in the positive direction, that is the extent like this, you can see a contraction. So a positive displacement, tensile displacement, will result a contraction. So to make the value mu positive, we use the minus value. Okay, so that is the minus sign applied here. This mu value is constant. That is very important here. This mu value is constant within the elastic limit. Within the elastic limit, not the proportionality limit. This mu value is constant within elastic limit, mu constant. Okay, in general, for isotopic materials, nu value is equal to, generally it is taken as 1/4. For structural steel, this mu is taken as 0.30. And also note that this mu has no unit. This mu is also a unitless. For concrete, this mu value can be taken as 1/8 to 1/12. For cork, this mu value can be taken as almost equal to 0. It means it is somewhat a rigid material, so that the mu value is taken as rigid than structural steel. So the mu value is equal to 0. Not equal to 0, it is almost equal to 0. So friends, I hope that you got what is Poisson's ratio. If you like the video, please subscribe the channel and support me, and if you like the video, please share the video, and we will see uh, with more definitions and tutorials in the next videos. Okay, thank you.